Hello again, dear grade 9 students. In this part, we are going to start new ideas. And the first new idea we are going to talk about is the equation of a straight line, and that's the most important idea in this chapter that's titled by Lines in the Coordinate System. In general, in a coordinate system, lines are represented by equations of the first degree. Equations of the first degree are called linear equations, and linear is from line. And the variables in this equation are x and y. So as you see here, the general form of the equation of the straight line is like that. Y equals ax plus b. Notice that y is written or is expressed in terms of x. This equation has no specific solution because for each value of x you are going to have a value for y. Now a and b are actually real numbers. So a and b are real numbers. For example, we have like this: y equals 2x minus 1. Y equals minus x, for example, plus 3. Here a is 2 and b is minus 1. Here a is minus 1 and b is 3, and so on. So a and b are real numbers and the only variables are y and x. So as you see, it is a linear relation between y and x, and this is the general form of the equation of the straight line, and that's called the reduced form of the equation of the straight line. Now a is called a slope. So again, this real number multiplied by x, which we call the coefficient of x, is called the slope. And b, this real number alone, that's not multiplied by any variable x or y, it's just a constant, is called the y-intercept. And the word intercept is like the word intersect. And let's see now what is the meaning of the slope and the y-intercept graphically using these photos. For example, you have this drawn line. Later, you are going to know and to learn how to draw lines and how to find these equations as well. But first step is to know and to identify the equation of a straight line and to identify the slope and to understand the meaning of it and of the y-intercept as well. The slope is related to the shape of the line. So as you see here, the line is, if we go from left to right, the line is increasing. That's to say that its slope is positive. So the slope controls the direction of the line, and it's related to some trigonometric ideas that you are going to take it later, but now we are only responsible about understanding the meaning of the slope in general and the relation between its sign and the direction of the line. So if the slope is positive, then the line is increasing because we move from left to right. As you see, we are increasing. While if the slope is negative, for example, as you see in this photo, in this image, the slope is negative. The slope of this line is definitely negative. So the line is decreasing as we go from left to right. So again, the slope controls the direction of the line. Now what about the y-intercept? From its name, the y-intercept is where the line intersects the y-axis, as you see here. So here, the line intersects the point axis, the x-axis, sorry, at this point, which is having just, it's, for example, let's say it is k 0 2. Why is the abscissa 0? Because k belongs to the y-axis, so the y-intercept is 2. Okay, so the y-intercept is the point or is the value where the line meets the y-axis. Now Let's see examples on straight lines using numbers. Y, for example, equals 2x plus 3, so the slope here is 2 and the y-intercept is 3. This is called the reduced form. If we write the line in this form, for example, 2y plus 4x minus 8 equals to 0, this is called the standard form. To change from the standard form to the reduced form, all what I have to do is to keep y alone and to write it in terms of x. So I start taking the other values to the next side, then 2y is minus 4x plus 8. Then dividing all of this equation by 2, I will get that y equals minus 2x plus 4. Then what is the slope? The slope is minus 2 as you see here, the coefficient of x, and the y-intercept is 4. So to sum up, in order to find and determine the slope and the y-intercept, I have to write the equation of the straight line in this form: y equals a real number times x plus something or even plus 0. So I need to keep y alone and the others in the other side. Now here we are going to talk about lines with special cases. Let's start by the first special case. In this figure, you have that the line D is passing through the origin of the orthonormal system. That's to say that B is 0, because the y-intercept is the value where the line is the ordinate where the line intersects the y-axis, and the line intersects the y-axis here, then y of O is 0. So the y-intercept, which is B, is 0. The line that passes through the origin have the general form of y equals ax. So we have to keep this in mind. And its slope is a. So the line passing through the origin has this form. Its b is 0, the y-intercept is 0, and the slope is a. If a is positive, then the line is increasing. If a is negative, then the line is passing through the origin and decreasing. Now here is a special line also. Notice the figure. We have a line D that is parallel to the x-axis. Then this line D has the form of y equals b. Notice that ax disappears here. That's why we say that the slope is 0. So it is as if we write y equals 0x plus b. So the slope is 0, and what remains only here is the y-intercept. So if b is 2, then the equation of this line is y equals 2. And definitely it is parallel, as you see, to the x-axis. If b is minus 1, for example, here, then the line has the equation of y equals minus 1, and so on. Now finally, here is line D that is parallel to the y-axis. That line has also a special equation, which is x equals to c, where c is any constant number. For example, c is 1.8, I guess 1.7. Okay, if for example c is minus 1, then we have x equals minus 1. How do I draw that line? I draw it like that, along minus 1. So you see, the line is parallel to the y-axis. Its form is, in general, x equals a constant number. Here the slope is not defined because y doesn't exist at all. So the slope here is not defined. So when the line is parallel to the y-axis, as you see here, it has the form of x equals a constant number depending on the intersection with the x-axis, and the y disappears, so the slope is not defined. And to make it easier, no y, no slope. Keep it in mind. No y, no slope. Slope is not defined. And here is a note. The equation of the x-axis is y equals 0. You have to know that. Here is, for example, the x-axis. Sorry, here is the x-axis. Notice that the x-axis never moves, neither up nor down. So its equation is just y equals 0. And the equation of the y-axis, as you see here, it doesn't move neither left, nor right. Then its equation is just x equals to 0. And you have to know the equations of x-axis, it's y equals 0, and y-axis x equals 0. So to sum up, the line that is, let's make a relation. The line that is parallel to the x-axis has the form of y equals a constant number, while the x-axis itself is y equals to 0. The line parallel to the y-axis has the form of x equals a constant, while the y-axis itself has the form of x equals to 0. So what differs is only that for the x-axis and the y-axis we have 0. For those parallel to them we have constants.